Okay, welcome back to part 2 of the first tutorial in this series. In this part, we're going to actually write our first controllers and be able to return something up to an HTTP client. We're going to use Chrome in this instance just to see the output for now. There's no real output, there's no backing data source or anything like that, but just to see that we can actually get it going. We've got the hosting right and we've got our routing right. So first of all, here we go. We'll add Kestrel to our two hosts because Kestrel is what we're going to host our services inside. We're not going to use HTTP sys or IIS or anything like that. We're just going to be using raw Kestrel. Right, now we'll add MVC, but we're going to add ASP.NET Core.mvc.core. And we'll add this to our libraries project. We won't need this in our host. The reason we add .core is because we're not going to need stuff like Razor pages, etc. in our pure web API project. We just need the minimum we need to get routing and a few other bits and pieces that I'll show you shortly up and running. So once we've added that, it brings in a few dependencies of its own. It should be pretty much all we need for now. So that's the Kestrel package on the two hosts and the MVC.core on the library. So once we've got that, we're then going to add a startup class. For now, we don't need to add anything else to it. We'll just make that public so our two hosts can gain access to it. The reason we're putting this up in the library is the startup class is going to have a lot of stuff configuring our actual services, which we don't want to duplicate over and over again in all our different hosts. Now we will create a new web host or iWeb host, and we'll do that using a web host builder. First of all, we're going to use Kestrel, so we need to do .use Kestrel on that. Next, we need to give it an API, a URL that it's going to listen to. So in this case, we're just going to say everything. So http://star, and then we're just going to put in 5000, which is the classic from all the templates. Finally, we're going to use startup, and then we're going to hook into that startup class from our library. Then we'll build the web host builder, which will give us a iWeb host, and then we'll run it. Now, the difference between run and start, as we'll see later, is run is a blocking call and will only return once the web host shuts down. Start is a non-blocking call. Clearly later on when we build a Windows service, we want a non-blocking call because we need to return from the method that's invoked as start by the service control manager. Now, the exception we've got here is because our startup doesn't have a configure method. So that's the very minimum you need is a configure method on your startup. So we'll head over now to the startup, put a public method on it called configure services first of all. So while we only need a configure method, we know we're going to need a configure services method, so we might as well add that while we're here. We're going to that takes in an iService collection. That's the only thing it can take in, and here we'll add MVC core onto that. That'll give us our basic routing, a much lighter weight version of MVC designed for web APIs. Then we'll add our iApplication builder onto our configure method, and on that we'll just call app.useMVC. So once that's done, we should have the basis of a hosted MVC application. Now, of course, we're going to have to actually add some code to use that. So we'll add a controllers and a models folder. So what I tend to do is not make a separate DLL for my models and not make a separate DLL for my controllers, because I try and keep each service relatively small. Now you say that might be a problem for things like finding those services, etc. But we'll show why that's not a problem soon. The other thing is what I tend to do is have a front-end service. So this may become our front-end service. Where say clients or external API users hit, and then this calls out to back-end services that actually have all the logic in it. So that way we get our separation through services rather than through hundreds and hundreds of DLLs and projects. So here we're going to make our basic object. We're going to have a user, and we're going to have a repo object because we want to store information about code bases, and that's the natural kind of separation that everyone knows from GitHub, Bitbucket, etc. is the idea of having a user or an organization in a repo. We can put organizations in later. We're not going to right now. We're just going to keep it really simple and build up slowly from it, rather than trying to build a massive complex model and getting confused by the model rather than what we're trying to learn. So now we'll add in our controller, and we'll call it the repo controller. So this will just be where you pull back information about your repos. Then after the repo controller, we're going to add a user controller as well, so you can get information about your user. Now we've added our user controller as well. We can start building up these controllers to actually return something or do something semi-useful. Make it public first of all. We're going to use convention based, so the fact that it's got controller on the end, MVC will pick that up automatically for us, and we'll include that in our route as well. So first things first, we'll make a method to get all of the repos out of the service. Now, right now, we haven't included any kind of authentication or semi-multi-tenancy in that. If you call this method, it will just give you all the repos. Clearly, that's not something we would go into production with, but once again, we're keeping it simple. We'll look at how to separate that data later on and how to do the various ways of authentication as well. So we're going to add a root at the top. Now, if you've come from just straight MVC and actions, you may be thinking, why do we need to add a root at the top? There's a couple of reasons. One is this is a web API. We don't actually have action routing because these aren't actions per se. Secondly, and we'll see this in the next tutorial set, is that we want to build Swagger documentation directly from our web API without having to manually do it, and then we want to build SDKs out of that. And in order to aid that, we need to put things like the HTTP get clearly on top. We also, and I'll show this shortly, we'll need to say if we're going to return an action type, because we might want to return not found or OK, but then we want to return a actual class, a serialized class inside of that, we're going to need to put tags on attribute tags on top of our methods in order to be able to tell the auto Swagger documentation tool what types that our methods actually return. So anyway, we've got null here, and we're just going to use the controller base from MVC. We're only doing this to base. We don't have to do that. MVC will actually pick up the fact just by the fact it's got controller on it. But we're doing this so that we can grab ourselves some of the helper functions, like I said just before, OK, not found, etc., etc. We can do those manually, but it's nice to have the helper functions, and we don't need to inherit off any sort of internal base class anyway, so there's no problem there. Now, for the user controller, we're going to have a method that you pass in a username to, and it returns a user object. And once again, we'll have a get all users as well, which will return an IEnumerable of users. Now, once again, we're not doing anything like paging or rate limiting or anything like that. We're keeping things really, really simple. So add the root at the top of this one as well. Now, you can see the root here is going to be slightly different. It's going to be API / and then directly the controller, because we expect people to do our API / our username. Say if it's Tim or Dres or whatever, then it would be API / Tim, and it would give me back the Tim object and all this sub stuff underneath it, which was a little bit different to the repo controller, because there we had /username /repo. Right. Now, we just checked that ran, it all runs. Now we actually need to return something, otherwise Chrome will just show us nothing on the screen, which is a bit pointless. So we'll just make up an array with 2 users in it, just so we can see some serialized JSON coming out. As I was saying before, we're going to have API / and then the username /repo, and by using the routes we can actually do that /repo and then you could have slash and then the repo ID as well to get more details out of it. And that's another thing. These objects here are almost like summary objects. We'll look later at having a summary object when you're returning lots of results versus having a full-fledged object when you're returning the details of one specific thing, like one user or one repo. We're probably also going to take a look at using Dapper to get information out of SQL Server. We'll have to think about that when we cross that bridge. And maybe Redis as well. Right, so that's our basic methods here. We're just going to have a if statement in here, and if the username equals dress, then we're going to return the user object for dress. If not, we're going to return the not found HTTP. So we have to return an action result. And here we return a not found. And then we have to go up here and return an OK and pass the user object into that. Now, as I said before, one of the effects of doing this is that we've now lost some information from our method because it's returning an action result. So Swashbuckle, which is the auto swagger tool we're going to use later, can't actually tell you what this method's supposed to return. So instead, what we're going to do is tag the top with producer's response type and say that if it produces a 200, it's going to return a type of a user object. So now we'll just fire up our server. Head over, try and load that up, and what do we get back? We get back a 406, which says not acceptable. So what this means is we don't have any formatters that are acceptable to turn that object type into what the browser is expecting. That's because we've used MVC core, which, as I said before, is a much lighter version, but it means it doesn't configure up all the formatters for you out of the box. So for now, we're just going to add the JSON formatters, which is mvc.formatters.json. And we could add the other formatters. There's some there. You can see there's an XML formatter. We might take a look at a protobuf formatter later on for more performant service-to-service communication, things like that. But for now, we're just going to add the JSON formatters. So we'll put that there. Now that comes off the where you have add MVC core. It actually returns an iMVC core builder, and that's what you add the JSON formatters onto, not onto the iService collection. Right, now it starts up, and hopefully, if we take a look in Chrome here, we should get a nice return. So this time we got a 200, and you can see we got the object. Excellent. So that's our basic web API. Now we'll go users/address, and we get nothing back. We get a 404 not found. Now, in theory, this should have worked, but I don't know if any of you saw the mistake that I made earlier. I'm looking here. Can you see the mistake? I've put a breakpoint in. We'll run it again in case you can't see the mistake yet. And do we hit the breakpoint? No. So that means it's a routing problem. We're not even getting into the first line of the method. So let's stop and take a look, and I'd put a slash in front of the HTTP GET, which means that it's bringing it all the way back. Instead of a slash, I just wanted the variable name directly. And now you can see we've hit our breakpoint. We've got the right values in the right place. We'll run it up, and the result is the correct record. So that's just one thing to be careful of in your HTTP GET, is not putting a slash or whatever in the front there and bringing your path all the way back. We'll take the slash out that we also had on the repo controller. That's the end of part 2. Thanks for watching, and I'll see you back on part 3.